Okay, so today we start lesson 5.5. Take a minute and look at the problem of the day. Correct the error before you move on to the lesson. All right, so today we start lesson 5.5, which is apply the remainder and factor theorems. We spent a couple days on this lesson. If you remember for chapter 5 so far, what did we do? We added, we subtracted, we multiplied and divided, but we didn't divide yet. So now we're going to finally take a look in 5.5 and 5.6, what happens with division, continuing on with the factoring, so on and so forth. So, example 1 says divide f of x equals x cubed plus 3x squared minus 7 by x squared minus x minus 2 using long division. So we're going to start with long division. There's something called synthetic division, very similar to synthetic substitution. That will be the next part of the lesson. But we have to start off with long division first. So when I write this with my big division box here, what's the first part goes inside. So x cubed plus 3x squared. Now you notice we don't have an x to the first, so I'm going to put plus 0x. Just like synthetic substitution, we want some placeholders here. Then minus 7. All right. Now, what we divide by goes out front, x squared minus x minus 2. Now, how we do long division is very similar to how you did long division with numbers back in the day. So I say, okay, what times x squared will give me x cubed? So what times x squared gives me x cubed? Should be x. So now I take that x, and you see there's 3 terms outside. Take x and I multiply it by all 3. X times x squared is x cubed. So remember, the first term has to match up exactly with the term we're looking at, the first term. If these two aren't exactly the same, you have to go back and change what you're multiplying by. All right, so x times x squared is x cubed. X times negative x is negative x squared. And then x times negative 2 is negative 2x. And then I draw a line. All right. Now, we know when we write this line below it, what was the operation we always did in math? We always subtracted, right? Well, subtraction's not the same with integer rules. Subtraction just means you change all the signs to the opposite. So this is a positive, becomes a negative, and you're going to see I like to circle my signs so I don't get confused, so I know I actually changed it. Negative becomes a positive. That's changed. And negative becomes a positive. So all of them on the second term, or the second line, you want to change them to the opposite sign. Now, x cubed minus x cubed, now they actually go away. And that's the whole goal of each first piece. 3x squared plus x squared is 4x squared. 0x plus 2x is plus 2x. And just like long division with regular numbers, we bring down the next term. We bring down one term at a time. And we're going to start all over again. Now, we go what times x squared gives me 4x squared, which should be plus 4. Remember, we want exactly the same sign initially because when we subtract, it'll go away. So, we want 4. 4 times x squared, 4x squared. 4 times negative x is negative 4x. 4 times negative 2 is negative 8. Once again, we draw our line. Now, don't forget, it's subtraction, which means in math, we switch every single sign on the second line. This becomes a positive. This becomes a positive. Now we evaluate. 4x squared minus 4x squared cancels out. So now we did it right. 2 plus 4, 6x. Negative 7 plus 8 plus 1. Now, you'll notice we usually start the highest exponent and work our way down. So what do we have? We have x to the first, then a constant. So my question for you is, what times x squared will give me 6x? Hopefully you realize we have to stop here. This is actually my remainder. I can't multiply x squared by something to get a lesser exponent. Here's x squared, x to the first. And I also know because I go x to the first to that constant. So we're actually finished. This is our remainder. I'll show you how we write it as a final answer. So I can't divide anything else. My answer now is x plus 4 plus, and if you remember back in the day, you have a remainder, you'd put like r, or we could write it as a fraction. So I'll say 6x plus 1 so it looks like an x over the front piece here, x squared minus x minus 2. So the remainder always goes over what you're dividing by. That's my final answer. Okay? All right, so let's try one more example. I want you to try to do this one yourself. Pause the video and set it up, and we'll go through it. So the first piece goes inside the root, or the division bar, I should say. So the first part always goes inside. What you're dividing by goes in front. So I ask myself, what times x will give me 3x cubed? So what times x will give me 3x cubed? We want 3x squared. So once I figure out that first term, I multiply it by all the pieces in front. 3x squared times x is 3x cubed. I know I did it right because it's the same exact thing with the same sign initially. 3x squared minus 3 is negative 9x squared. Now this time there's only 2 terms, so you only multiply what's out front and stop. Subtraction means I switch my signs. This is now negative. This is now plus. They go away. 17 plus 9 is 26x squared. And you could bring down more than one term, but I usually only bring down the next one, so plus 21x. And then I ask myself again, what times x gives me 26x squared? Hopefully you get plus 26x. Now I take 26x, I multiply it by that. 26x times x is 26x squared. 26x times negative 3 is negative 78x. Draw my line. This positive becomes negative. This negative becomes a positive, and I like to circle it so I remind myself that I completed the opposite sign. These go away. 21x plus 78x is 99x. And then I bring down the minus 11. Keep bringing one term down at a time. So I got to do it again. What times x gives me 99x? Positive 99. 99 times x is 99x. 99 times negative 3 is negative 297. Draw your line. Change my signs. It's negative now. This is a positive. And circle them. This goes away. Negative 11 plus 297 is 286. And I know I'm done for a couple reasons. What times x gives me a constant. I can't decrease. And also, what do we have here? X squared, x to the first, and constant. So that's also how you know you're finished. So let's write our final answer. 3x squared plus 26x plus 99. And this is a remainder. Once again, a remainder is a fraction, so plus 286 over what we're dividing by, x minus 3. That's my final answer. Okay, that's it for the lesson today. For homework, I want you to do the problem of the day, and then also complete the following problems in assignment 11, numbers 1 and 8. I want you to do 2 practice problems, and then in class tomorrow, we'll pick up with that, and you'll finish the rest of assignment 11.